Right, welcome to today's stream. We're going to be looking at questions, which are going to be mechanics questions today. And they're going to be primarily going to start off with just constant velocity questions, introducing the vectors. So you get to understand how to do, how things move and to work out displacement between two things using constant velocity problems. Then there's a constant acceleration one to finish off. Now, here's our first question. I'm going to give you 5 minutes to have a go at this one. So, without further ado, let's get started. One minute to go. Right, so here we go. We're going to look at this question, and the first thing we've been asked to do is calculate the speed of v, so p even. So the speed of p will be equal to the magnitude of the velocity, which is equal to the 4 squared plus the 8 squared, all square rooted. And that comes out to be the square root of 80. And that's equal to 8.9 meters per second if you want to calculate that. So that's part A. Part B, what we got here is we want, when t equals 0, the boat's p has position vector 2I minus 8j. At time t hours, the position vector is p. Write down p in terms of t. So it's going to be its initial position, which is 2 minus 8. And I'm going to write them column vectors rather than i's and j's. It doesn't matter which you do, you can do either. I prefer to write column vectors because I find that they lead to easier seeing of the equations that you want to deal with later. So we're going to get minus 4 and 8 times by t. So there we go. So we've got the position at any point in time is equal to the initial position plus the velocity times by the time. Now, next thing, we're given a second boat with second velocity, and we want to find when it's due west of Q. So if we're thinking about this, we got north, south, east, west. Okay. You know that when it's due west, the j components will be equal. So the j components of Q and P will be equal. So therefore, the j components, 12 minus 8t will equal minus 8 plus 8t. And therefore, we're going to get 20 will equal 16t. So t will equal 5/4 seconds. Now for part D, let's do it over here. We're going to find the distance between P and Q when P is due west of Q. Now the thing is, the magnitude, we want to find the magnitude of P to Q as a vector, but we don't need to worry about the J's because we've just shown they're going to be 0. So therefore, all we need to do is worry about the I's at this point. So therefore, we're going to just take away the P from the Q value to get from P to Q when doing vectors. So what we got is, we've got the Q bit, so we've got 18 minus 6 times T for 5/4. And we're going to take away from that the p part of the I part of the p part of the vector. So we've got 2 minus 4 times, what was that, 5/4 again. And when we work that all out, we get 27/2, and I think it's going to be in kilometers. You can write that as 13.5 if you really want to. No questions in the chat, so let's move on to the next question. And I'll just make that a bit bigger for you to look at. And we'll give you again 5 minutes to get started on this. These are in the exam, you'd get 13 minutes. But if you really know what you're doing, you'll get these nailed in 5 minutes. And for the purpose of this video, you can always pause it when you're watching it later. Notice this is meant to be a -1. Something went wrong with the database when it's producing this question. And for the purpose of this video, you can pause it later to give yourself full time if you want more time. But if you really know this topic, you should be able to finish it in about 5 minutes. So off we go. 1 minute to go. Terribly sorry, forgot to turn the mic on for the whole of that question. Apologies for that. I'll leave the mic on for this one. One minute to go. Okay, so Hopefully you can hear me now. Question 3. Two ships P and Q move in constant velocities. Ship P moves at velocity 2I minus 3J, and ship Q moves at velocity 3I plus 4J. Let's just make this a bit smaller so we can see more of the paper. And just move the next question out of the way. There we go. So that'll give me a bit more space to work with. Find to the nearest degree the bearing which ship Q is moving. So ship Q is moving this way, and it's going to be going 3 that way and 4 that way. So this is Q moving that way, and we want to find, well, we're going to find that angle. So tan of theta equals 4 over 3. So theta will equal 53 degrees. So therefore the bearing will equal 037 degrees, taking this 53 away from 90 because all bearings are taken from north. So that's part A. Part B, we're going to write down expressions in terms of T for P. P is a point, is at the point position vector ij at 2 p.m. So we're going to have 1, 1. And then we're going to add on to that T lots of this. So 2 minus 3 lots of T. And we're going to do, that was part 1. And part 2, we've got Q is equal to, what we've got, it's going to be at 0 minus 2 to start with, plus, and it's going 3, 4. Lots of T. And we want to find PQ. So PQ, when you're working out PQ, you've got to take the P vector away from the Q vector. So you're going to take all of this away from this. So we're going to get minus 1 on the I, I'm going to get 2 away from 3 gives me plus 1 for this bit. I'm going to take 1 away from that to give me minus 3 for that constant bit. And then for the T bit, we've got minus 3 away from 4 will give me 7T. Now we want to find the time when Q is due north of P. Now if Q is due north of P, remember it's going to be directly above, so the I bits of this will be equal to 0. So 0 will equal minus 1 plus T, so T will equal 1 second. Not 1 second, 1 hour I think it is. We're doing kilometers per hour. So therefore it will be at 3 p.m. because it was 2 p.m. when it started. Part 2, we know that northwest, then we know that the I's and the J components, if we're northwest, we're going to be that way. Then what we realise is that the I's will be equal to the minus the J's section. So therefore, we've got minus 1 plus T will equal minus this, 3, minus 7T. So we get 8T will equal 4, so T will equal half an hour. So therefore, the time is going to be 2:30 p.m. Right, our last question. Let's just page down and have a look at that. Let's make it a bit bigger for you to see. So this is a much shorter question. It says total 5 marks. I haven't got a timer for this, but I'll give you 3 minutes. So the feed is at 31:53, so we'll go through this at 35 minutes. Just a few more seconds on this one. Okay, so here we go. Looking at this question, particle P moves with constant acceleration 2 minus 5j meters per second. At time t equals 0, P has a speed u meters per second. At time t, P has a velocity of 6I plus j. So if we use, we could use V equals u plus AT. There's a lot of ways to do this question. So we've got V is 6, 1. We got u. We don't know u, so we could just put u. Actually, I'm going to split this up into two components actually to make it easier. I'm going to go ux and I'm going to go uy plus, and I've got a is 2 minus 5, and we're going to times this by 3 because t is equal to 3. So therefore, minus 6 equals ux plus 6. So therefore, ux will equal minus 12. And then we got 1 will equal uy minus 15. So uy will equal 16. Now we want to find the speed u. So u will be equal to minus 12. Sorry, let's just rub that out and write that properly. Will equal minus 12 all squared plus 16 squared square rooted, which is equal to 20. What's this in meters per second? So there we go. That's the constant acceleration and constant velocity with vectors section of this revision sheet done. Remember, doing these revision sheets in preparation for a test in 3 weeks' time. Next, we'll be going back onto pure, and we'll be looking, I think, in the pure questions, what the topics we're going to be looking at next. Looking like we're going to be doing some differentiation and looking at how things change during that time when we differentiate. Okay, so we'll be looking at some of that for next, probably it's going to be Friday, our next stream, if for those of you who are keeping in touch with this. Cheers. Thanks very much.